Before we start, we will give you exactly 30 seconds to try answering this on your own, together with the questions that can be found on the right-hand side of your screen. If you think you need more than 30 seconds, you may pause this video before the start of the discussion. If you think that you don't need the 30 seconds, you may skip this video to the portion of the discussion. Your 30 seconds starts now. For the expansion of this given binomial expression, let's refer to the questions here. The first question will help us determine the correct coefficients needed for the expansion, while the last two questions will be answered once we are done with our process. So we have here the binomial expression 2c minus d, which is raised to the power of 5. The first thing we need to do here is to determine the number of terms, so that in our Pascal's triangle, one of the processes that we could do, we can actually determine the correct set of coefficients. Here, our exponent is 5. So we can say that n is equal to 5. Whenever we have an exponent here, it could automatically tell us what the number of terms, okay? The number of terms is n plus 1. So if we have the exponent here being 5, we expect to have n plus 1, 5 plus 1, we have 6 terms. Okay, so in our Pascal's triangle, we need to look at the set of coefficients, which has 6 coefficients, and we're going to use it to determine the expansion later. So our Pascal's triangle will have like this: 1, then you have your 1, 1. So 1 still here, 1 plus 1, you have 2, another 1. So that's a 3. We need to have 6, right? 1, 3, 3, 1. We have 4. 1, 4, 6, that's 4, another 1, that's 5 coefficients. In short, the next row, 1, 5, 10, 10, 5, and 1. This would be the set of coefficients that will be used for our expansion, because we know that there should be 6 terms in our expansion. In short, it could look like this: equal to this entire expression. We have 1, we have here plus the next coefficient of 5, we have here plus the next coefficient of 10. Notice that we are using addition here. Some of the signs will be changed later, since our middle sign here is negative, or it's subtraction. But just for the structure of the coefficient, let's just use addition. Don't worry, it will be changed to subtraction if necessary. Let's continue. You have plus another 10. You have here plus 5. And last one plus 1. These are the coefficients: 1, 5, 10, 10, 5, 1. But these are not yet the final coefficients. For some of us, you might jump a number 3 question, numerical coefficient of third term, and you might say 10. It's not yet the final, since notice here, our first term has a coefficient other than 1. Because if you have that, you have here your first term, and you have here your second term. Take note of our second term, we also included the negative sign. We will use here the decreasing orders of exponents for the first term. So we will have here 2c, not raised to the power of 5, but because the exponent is 5, but we need to make sure that we enclose the entire term, not just c itself, but it's 2c raised to the power of 5. Okay, and then we go down, 2c raised to the power of 4. It's very essential to enclose it in parentheses, so that your exponent will also be given to your numerical coefficient. So you have 2c raised to 2, you will have 2c raised to 1, and finally 2c raised to 0. So we have a decreasing order of the exponent of the first term, not just the numerical, not just the variable, but the entire coefficient, which includes the numerical coefficient. Similarly, on our second term, we will do the same process but on opposite direction. Let's start here, negative d, and your highest exponent is 5. But same thing as earlier, enclose it in parentheses so that your negative sign will be included in your exponentiation. Similar here, negative d, 4, right? Because we are going down or in decreasing order here from right to left. Negative d cube, and then negative d, you have square, then negative d raised to the power of 1, and finally negative d raised to the power of 0. We need to use this in together with our terms from the Pascal's triangle, and we're going to pair each of these to the corresponding coefficient. In short, the first coefficient is 1, then you have 2c raised to the power of 5 times negative d raised to the power of 0. Okay? Next, plus 5. It is what I meant earlier, that these coefficients are not necessarily final because you have here 2c to the power of 4, and you will have a multiplier of 4 here, but still to be given with the exponent. Then negative d to the power of 1. Then plus your third term, 10. This was your second pair. Your third pair is this. Okay? Take note of that. You have 2c cubed and negative d squared. Let me continue here at the bottom because we don't have much space. This next pair will be paired with the coefficient of 10, the second 10. You have 2c squared, then negative d cubed. Then you have here plus another 5. You have this pair. So you have 2c to the power of 1, the negative d raised to the power of 4. And finally, hopefully we can have space here, 1. Then you have 2d raised to 0 times, that's 2c. Okay, pardon. Our first term is 2c raised to the power of 0, and the negative d raised to negative 1. Pardon for that. Then we do it step by step. Of course, that's 1. Any expression, term coefficient raised to 0 is also 1. So you have 2c. So 2 to the, let's have it like this at first. 2c to the power of 5. And you have here plus 5. Or we could just simply automatically do it like this. We have 2 to the power of 5 distributed at 1. You have 32c to the power of 5, right? Because 2 to the power of 5 is 32. Plus 5 times, that's 16 c to the power of 4. Take note, I still have here parentheses because I still have this one here, negative d, as it's the result when I have exponent of 1. Then plus 10, you have 8 c cubed, and the square of negative d is just d, plus this here, you have 10, you will have times 4 c squared, and the cube of negative d is also negative d cubed. Next, plus 5 times 2c, because 2c to the power of 1 is just 2c, times this one here, negative d raised to the power of 4 is positive d. And finally, plus 1, and the expression raised to 0 is 1. So you have here, sorry, this is not negative. This is, sorry, that is 5, my bad. Okay, so negative d raised to the power of 5 is still negative d, but raised now to the power of 5. Okay, so finally, let's combine everything here. 32 c to the power of 5. Then 5 times 16 is 80. But take note of a negative sign here. So negative 1. So minus 80. As you can see, the negative sign prevailed. C4D. Okay? Because we have here. So that is why no need to worry if we use plus signs here, because it will be changed as well. So you have here plus, still 80 if I'm correct. Okay, 80 C cube. Sorry, this is D squared. That's D squared. My bad. D squared. So as you can see, I also have some corrections to be made. So always review your result. That's 10 times 4 is 40, but you have a negative sign here. So minus 40 C squared D cubed. Then for the next, this is D to the power of 4, right? My bad. So you have plus 10 C D to the power of 4. So please make sure that your exponents are correct. I'm going to teach you one way to determine whether your answer is correct or not. Of course, the last one is negative D to the power of 5. Here's the hint, and this is also the reason why I was able to check my process earlier. Notice the degree of each term. You have 5. You have 4 plus 1, and that's 5. 3 plus 2 is 5. 2 plus 3 is 5. We have here 1 plus 4 is 5, and 5. You would know that all your answer here is correct if first and foremost your exponents will add up, or the degree of each term will meet the degree of your original binomial expression. I noticed here earlier that my expression will not equal to 5. That's why when I look back here, I forgot to place 2. That's the same thing here with 4. I forgot to place 4. That's one thing that you could also check. Now let's proceed here to the answers to the question. What is the fifth term? 1, 2, 3, 4, 5. This is the entire fifth term. So you have 10 C D to the power of 4. And the numerical coefficient of the third term, again, is not 10, but because this is our third term, your numerical coefficient is positive 80. So we are done with expanding the binomial 2c minus d raised to the power of 5, considering all these steps. Please subscribe if you have not subscribed, or share this video so that we could also share the ideas here presented in expanding binomial expressions. So thank you very much. Goodbye, everyone.